All right, and welcome back. So today we are going to be talking about how to solve inequalities that have variables on both sides of our inequality sign. This is going to be very, very similar to solving equations that have variables on both sides. We will have some special cases, and we're going to be going through an example of each type of special case, being an all real numbers. You also sometimes hear that as many solutions, and a no solution. So without further ado, let's begin. So let's go through this first example. Now, your guided notes has it where it asks you to collect variables on one side of the inequality, whether collect on the left or how to collect on the right. So let's go through example 1, which is about how to collect your variables on the left-hand side of that inequality. We have x is greater than 8 times the quantity x minus 7. So we notice we have variables on one side, which means we have on both sides, I should say. So we need to get our variables to one side and what we call our constants to the other. So first thing we are going to have to do here is we're going to distribute that 8 to the x minus 7. When we do that, we end up with 8x minus 56 on the right-hand side, and we still have that lone x on the left. We want to get our variables on the left-hand side here, which means we need to move that positive 8x over to the left, so we're going to have to subtract 8x on both sides. Sometimes you hear it called adding, negative 8x. It's the same thing if you're adding a negative or subtracting, but you can just say I'm subtracting 8x on both sides. We can simplify 1x minus 8x is negative 7x, and that's still greater than negative 56. Our x is not isolated yet. We have that negative 7 as a coefficient. So we have to divide both sides by negative 7. But be aware, since we are dividing by a negative number, and we are choosing to do that on both sides, we have to flip the inequality sign. Currently it's greater than, so it's going to get flipped to a less than. Our x is going to be isolated, and we're left with x is less than 8. Again, because we divided by a negative 7, that inequality flips from a greater than to a less than. So we have x is less than 8, and we have our variable first, our inequality sign, and then our constant, or the number that we are comparing it to. So this is in that proper form. We always want to have our variable first, because it's going to be a heck of a lot easier for us to graph it and to analyze when we get more complicated inequality results. Awesome. Let's go on to the second example on your guided notes, which is in the same section, but now we're going to collect the variables on the right-hand side of that inequality sign. And our answer should still be the same, but let's just verify and make sure that we can do that as well. So we're going to rewrite it, and the same first step is going to happen. We're going to distribute that 8. So we have x is greater than 8x minus 56. I want to have my variables on the right-hand side because that's what the directions are asking you. Normally, we're just going to say, hey, solve it or simplify it. We aren't going to specify whether on the left or on the right. You are just going to be given that choice of what you want to do. But let's show how we would get it on the right-hand side. Well, we need to move that positive 1x to the right, so we have to subtract or add negative 1x to both sides. In doing so, we're left with 0. A lot of students forget that we have 0 there. Well, anything minus itself is 0. It's not empty. We still have to write the number 0. We have our x's on the right. We want to get our constants to the left-hand side, or our numbers in comparison to the left-hand side. Well, we have a negative 56 on the right, so we're going to have to add 56 to both sides. In doing so, we get 56 is greater than 7x. Our x is not isolated just yet. We have that positive 7 as a coefficient, so we're going to divide both sides by 7. And since we're not dividing by a negative number, it's going to stay as the same inequality sign. So we have 8 is greater than x. We still have that greater than sign because we're not dividing by a negative. But we want to have our variable first. So we're going to switch the order here. You have x is less than 8. And x is less than 8 is going to be your final answer. It's not 8 is greater than x, pardon me. It's x is less than 8. We want to have that variable on the left because it's going to make it easier for us to graph it as well. All right, folks, with that in mind, please work on problems 1 through 6 on the note sheet and resume when you are ready to move on. All right, if you're listening to my voice, that means you are ready to move on. So let's talk about an all real numbers. We also sometimes hear called a many solutions or an infinitely many solutions example because we have variables on both sides. So we are going to potentially have these special cases. So let's go through an example. So let's say we want to solve this inequality. Negative 2x minus 5 is less than or equal to 4x plus 8 minus 6x. Just like we normally would when it comes to equations, we need to simplify both sides first. So we're going to rewrite it. We're going to combine some like terms. We're going to combine 4x and negative 6x since it's on the same side of the inequality, and we end up with negative 2x plus 8. You might notice something here. We can't simplify anything on the left. We can't simplify anything on the right anymore. But we do have the same term with the variable on both sides. We have negative 2x and negative 2x. That's on both sides of our inequality sign. But we can't make a statement just yet. So we're going to want to move our variables to one side and see what happens. So we're going to add 2x to both sides. In doing so, we're left with negative 5 is less than or equal to 8. With an equation, this would be a no solution because negative 5 is not equal to 8. But since we're dealing with an inequality, we want to ask ourselves, is this true? Is negative 5 less than or equal to 8? We think, yes, it is true. So since it's a true statement, we're going to say our answer is going to be all real numbers, infinitely many solutions, many solutions. There's a lot of different ways to answer this question. But the main difference between an equation and an inequality is with an inequality, we are comparing those two numbers. We're saying, hey, is negative 5 less than 8 or less than or equal to 8? Yeah, it is. So that's how it's going to be a true statement. If we end up with a number being less than or equal to or greater than or equal to or less than or greater than a number and it's true, we're going to end up with an all real numbers answer. But let's look at the opposite of that. Let's look at an example when it comes to a no solution. So let's say we have this inequality. 3 times the quantity x minus 4 is greater than 7 plus 3x. Just like equations, we want to simplify both sides. We can't do anything on the right-hand side with 7 plus 3x. Those are not like terms, but we can distribute that positive 3. So we get 3x minus 12 is now greater than 7 plus 3x. And we can't combine any like terms on the left-hand side, nor can we combine any like terms on the right. So we want to move our variables to one side and the number in comparison to the other side. Well, I notice I have the same term of our variable, the same coefficient of 3. So we're going to subtract 3x, or sometimes you hear it as being add negative 3x. It's the same thing. And we end up with negative 12 is greater than 7. And we need to think to ourselves, is this true? Is negative 12 greater than 7? No, it's not. It's a false statement. This is sometimes called a contradiction, but there are no solutions because our variables canceled out and we're left with a false statement. So just like equations, it's a false statement, it's going to be a no solution. With an all real numbers, it was a true statement, it's going to be an all real numbers. But now we have to think about how we compare the numbers because an inequality sign is comparing two values in the general realm of things. So since we have negative 12 is greater than 7, we know that's false. So this is going to be a no solution. And your final answer would be no solution. I see a lot of students falter with this because when it came to equations, we could determine if it was an all real numbers or a no solution pretty quickly. Because if our variables canceled out, then we have either the same constants or different constants. And here for inequalities, we can't make that assumption early on. We have to go through the problem until we get to a final statement comparing your constants or comparing the numbers of comparison before we can justify saying an all real numbers or a no solution. With that in mind, folks, please work on problems 7 through 11 on the note sheet provided. If you have any questions, please jot them on the Edpuzzle or on the video, and please bring them to class. You're working really hard, folks. You're doing really well. I will see y'all in class. Have a good one.